rational functions, that is where you have one polynomial divided by another one. Basically what that is. So you have one polynomial divided by another polynomial. And the most basic one could be considered to be this function here, 1 over x, where the polynomial in the numerator is just 1, and the polynomial in the denominator is just x. And this one right here, the graph looks something like this. Okay, that's what the graph of y equals 1 over x looks like. So you have, as you go to infinity, as you go out here along the x-axis towards infinity, then this is getting larger and larger. So 1 divided by larger and larger, that's going to 0. And then likewise as you go to negative infinity. So the y-axis is a horizontal, the x-axis is a horizontal asymptote. Meanwhile, the y-axis, as you come in this way, you get smaller and smaller numbers here. So like 1 divided by 0.001 is actually like 1,000. And so as you get, x gets larger and larger, this goes up to infinity. And likewise as it goes, so x equals 0, or the y-axis is a vertical asymptote. Okay, so first of all, the asymptotes are really important, and they happen to be zeros. Typically, you're going to have a vertical asymptote when you have a 0 of the denominator. The only case where that doesn't happen is where you have something in the numerator to cancel it out. So essentially, 1 over x minus 7 would have a vertical asymptote at 7. Okay. Also, a negative 1 over x minus 7 would also have a vertical asymptote, but it would behave slightly differently. So having a vertical asymptote means that as you approach, this means you come in from the right. So you approach 7 from the right. So like, for example, here, this is approaching 0 from the right up here. And then this is approaching 0 from the left as it goes down here. So as you approach 0 from the right, it's going to infinity. As you approach from the left, it's going to negative infinity. Okay, so if it has a vertical asymptote, then as you approach from the right, it's either going to go to negative infinity or positive infinity. And likewise, as you approach from the left, and these could be different, or they could be the same. Okay, so if it's like that, it's going to be different. If it's like this, then if it's squared like that, then either way, it's going to approach infinity. Okay, it approaches. This goes to infinity as x approaches 7 from the right, and as x approaches 7 from the left. Both go to infinity. But here that splits. This goes to infinity. This goes to negative infinity. Okay, horizontal asymptotes. Take a little bit about that. If the rational function has horizontal asymptote 7, then it's approaching 7 as x to infinity. So here it's a horizontal asymptote at y equals 0 is horizontal asymptote, and so it approaches 0 as you go to infinity, and also as you go to negative infinity. We'll talk a little bit later about how you can identify that from the expression of the rational function. Let's go on to this one right here. So number 3 is you have this function here, and we're supposed to identify the X-Intercepts. These will be zeros of the numerator, and they're going to be, in this case, it's going to be -1, and so it's going to be -1 and 3. Okay, and the Y-intercepts, to find that, you calculate R of 0. You plug in, you set x equal to 0. So basically, it's going to be 0 plus 1 times 0 minus 3 over 0 plus 3 times 0 minus 6. You make all these x's zeros, and you just figure out what that is. So this would be 1, that's -3, so it's -3 up there. This is 3 and -6, so 3 times -6. The negatives are going to reduce. the 3's are going to reduce, so you get 1 over 6. Okay, vertical asymptotes. Okay, so these are going to be typically zeros of the denominator. Okay, unless they can be canceled by the numerator. Canceled by terms in the numerator. Okay, so here we have -3, and that one is 6. So those will be vertical asymptotes. Okay, so x equals, and the equation is x equals -3 and x equals 6. Those are the equations. Okay. And the horizontal asymptote. Let me explain this case really quickly. There's three cases. What we're dealing with here is, so case 1, where the degree of the numerator equals the degree of the denominator. Okay, so let's just talk about this case for now. Here, if you were to expand this out, I'm not going to expand it out, but the highest order term would be x squared here. That's going to be x squared. The highest order term is going to be x squared here. Okay, so if they're the same, and this is the highest order term, you got lower order terms going on the highest order term, then y equals a over b is the horizontal asymptote. Okay, you just take you just focus in on the highest order terms right here, and their coefficients, the coefficient of the term in the numerator divided by the coefficient of the term in the denominator is going to be the horizontal asymptote. So in this case, we're focusing on that, and basically the coefficients are 1. Okay, so y equals 1 is the answer to number 6. Okay, that's the horizontal asymptote. Now let me run through the other two cases. The case 2. This is where the degree of the numerator is less than the degree of the denominator. And in that case, y equals 0 will be the horizontal asymptote. So you have a lower degree term up here. So instead of an x squared, let's say you just had an x. Okay, or so then instead of 2 terms here, you only had 1 term. Then y equals 0 would be the horizontal asymptote. And then case 3 is where the degree of the numerator is greater than the degree of the denominator. And in this case, there's no horizontal asymptote. Okay, there could be a slant asymptote. Okay, and the very last problem, we'll talk about that, slant asymptote. And if you want to find the slant asymptote, you use long division. And I'll show you how that works. Okay, I'll give you an example of that later. Okay, so we got a lot of more problems to do. Number 7. So here we have another exercise. And here, so the the first question. The graph of R has a vertical asymptote at x equals -1. Okay, that term, -1, is a 0 of the denominator. But notice, remember what I said, unless there's something in the numerator, they'll cancel it out. And if you factor this, the numerator, you get x times x plus 1. And also, you can pull a 4 out of the denominator. To get that. Okay, and then these are going to cancel. This will, when you do that, it leaves a hole in the graph. So, and you get x over 4 times x minus 3, but it's not defined when x equals -1. So it's the same as this function, except that this function here is not defined when x is -1, because you can't plug it in. It makes the denominator 0. It also makes the numerator 0, but you're not allowed to cancel that off. Okay, so the graph has a vertical asymptote. This is actually false, okay, because like I said, it really reduces down to that. This has no vertical asymptote at -1. The graph has a vertical asymptote x equals 3. That's true. That's true. Because 3 is a 0 of the denominator. And it can't be canceled off. Okay, part C, the graph of R has a horizontal asymptote at y equals 1. Okay, so here, if you expand everything out, you get x in the numerator, you get 4x minus 3. These are the highest terms, the x and the 4x. So 1 over 4 is a horizontal asymptote. Okay, so that's this one right here, which means that's false. So 1/4 is the horizontal asymptote, 1 is not. And then number 8, part D. Wait, number 8, okay, the graph of a rational function may cross a horizontal asymptote. That's true. It can cross the horizontal asymptote. It can't cross a vertical asymptote, though. Okay, number 9. Okay, so number 9, we have this function here, and we have all these values that we want to calculate. And this is to kind of give you information about what happens. As you can tell, this has a vertical asymptote. At x equals 6, and a horizontal asymptote y equals 4, because it's 4 over 1. The x's are the highest order term. So y equals 4. X equals 6 and y equals 4. Okay, so now I'm going to do this part, I'm going to show you how to do this in Excel. So basically, we're supposed to plug in all of these values in for x and into this function here, okay? Which is 4x plus 1 over x minus 6. So when I put this in Excel, I'm going to put the equal sign, and I'm going to put 4, and then parentheses, I'm going to put 4 times, and then I'm going to put the cell where these numbers come from, plus 1, close parentheses, divided by parentheses, the cell where this comes from, minus 6. Okay, so I'm going to go over to Excel right now. Let's see, where is it? Okay, now I've already put in all the values that we need to calculate. Okay, so like I said, I put in equals, and then I put the numerator 4 times, and then I put the cell, which is A2, plus 1, and then divided by, and in parentheses, I put the cell A2 minus 6, like that. Okay, so this cell is A2. And so I hit enter. That gives me the value there of -46. I can either double click there or I can just drag this down and that calculates all the values for me right there. Okay, I'll post this spreadsheet on Canvas and the files, but this is all of the answers right there. And it says though that they need to be rounded off to 3 decimal places. So you'll have to round some of these ones off to 3 decimal places. Okay. Okay, so that's all the values right there. Again, I'm saving that. I'll put it up on Excel. This is the important part, the A2. When you scroll this down, it goes through it just goes down with it. I'm sure you guys are familiar with this. Okay, let's go back. And I'm just going to put in the answers that I got. So this was -46. This is -246. This is -2496, and this is -24996. This one was 54, 254, 2504. Wow, that's weird numbers there. And then down here, 10.25, and then rounding to 3 decimal places, 4.568, 4.266, 4.025, 2.438, 3.554, 3.764, and 3.975. Okay, so let's try to analyze what's going on here with each of these. Okay, the reason that they're having you do this. Okay, so here you see these numbers are approaching 6, right? These are going to 6 from the left. Okay, this is going to 6. These numbers here are going to 6, but from the right, through values that are greater than 6. These values are all less than 6, but they're approaching 6. These are values that are greater than 6, but they're approaching 6. Now, these numbers here get larger in magnitude, but they're negative. So this means that as you go to 6 from the left, you're going to go to -infinity. Okay, so that's this one right here. And let me get a different color. And this one right here, as you go to 6 from the right, that's these ones. You're going to +infinity because this is getting larger. You know, I mean, this is just like from 0.01 to 0.001. That's a teeny tiny. That's 1/1000th, but it grew by like 10, like a pretty big amount. It by about 10-fold. And going from here to here, and it's just going to keep getting bigger as you get closer and closer. Okay, so part C, determine the horizontal asymptote based on tables 3 and 4. Okay, so and then 3 and 4 give you the horizontal asymptote. You can kind of see from these two that these numbers are getting close to 4. Okay, that's going to 4, but you're slightly bigger than 4 here, you're slightly smaller than 4. Okay, so these are really big numbers, and if you put even bigger in, you can go back to Excel and like experiment with even larger numbers and see what happens. But you're going to 4, and that corresponds to having a horizontal asymptote of 4. And then also these two parts right here, these two, 1 and 2, have to do with the vertical asymptote. X equals 6, and these two tables have to do with the horizontal asymptote. Y equals 4, and what happens with the graph. Okay, any questions about that? Great, let's move on to number 10. Okay, so here we're supposed to use transformations of the graph y equals 1 over x. So remember that graph I told you guys looks something like this. Okay, here, this graph, all right, dang it, I didn't put a space there. So it's s of x equals 3 over x plus 4. So that's 3 times 1 over x plus 4. Okay, so comparing this and this, this is inner, and it's plus 4. So that means that it's going to move. So it's gonna move the graph left, or what's the word? Okay, translate. I'll just say move. That's probably wrong, but move 4 to the left. Okay, and also you can kind of tell that x equals -4 is a vertical asymptote. Okay, so here x equals 0 is a vertical asymptote. So you're going to move that 4 places to the left, and then the 3 is just going to be a vertical stretch by a factor of 3. But the main thing is you're just going to move this to the left, and then stretch it vertically. So it'll be a little bit more. It'll just be stretched vertically. Okay. So let's look at this part right here. Move it left by 4. That one is great. That one's not good because you should have the horizontal. You should have a vertical asymptote there. So that's out. That's also out because you should have the vertical asymptote there. Okay, here this is fine because you got the vertical asymptote there. Now, didn't say anything about reflecting through the x-axis. This one's been reflected through the x-axis. Okay. No x-axis reflection. That would have happened if you had a negative out in the front here. If you had a negative out in the front, it would have reflected it. So this has got to be the answer right here. Okay, and then as far as the domain and the range, okay, the domain, you just have to exclude the -4. You can do it that way. And then for the range, you just have to include 0. Okay, because -4 is where you have a vertical asymptote. It never has to hit that. 0, it just never hits 0. This can never be 0. So in order for this to be 0, you'd have to have the numerator being 0, but the numerator is always 3. It's never 0, so this can never be 0. Okay, so that's going to be the range. Okay, number 12. No, I'm sorry, number 11. Okay, use transformations of the graph y equals 1 over x to graph this. And this is, this should be R. My goodness, such sloppy stuff here. Dang, I really messed that up. Okay, so anyways, here's what you do. You've got x plus 4 over x plus 5. And again, 1 over x is going to be like that, right? Okay, so what you do with this one is you use the division. Okay, so you divide. Okay, so I'm going to put so it's x plus 4 divided by x plus 5, right? So that's going to be a 1 there. Multiply those together, you get x plus 5 subtract, that's a -1. So that means that this function here, this guy right here is actually 1 from the 1 from there, minus 1 over x plus 5. Okay, or let's write it this way, -1 over x plus 5 plus 1. Okay, so from this graph to that, let's look at everything. So this plus 5 is, so here's the x right here. The first thing is it's got plus 5 to it, right? So this is inside, which means it moves left by 5. Okay, that'll be the first thing. Second thing will be this minus here, and that is reflect through the x-axis. So it'll be a vertical, this is outside, so it'll be a vertical reflection through the x-axis. So this has been shifted over by 5 and then reflected. And then this last thing, this is outside, it'll be a shift up by 1 because it's plus 1, so that's shift up by 1. Okay, also, what this means is that there'll be a vertical asymptote at x equals -5, and this means that your horizontal asymptote will be y equals 1. Okay, so let's look for those two things, and then we'll worry about the reflection through the x-axis. Okay, so this one has it at 5, so that's off. It has a vertical asymptote at 5 instead of -5. This one looks good there and there. The vertical asymptote is here. The horizontal asymptote is at 1. Here, both of these, the horizontal asymptote is at y equals 1, so they're both out. Okay, so all those are out. Now, also, you notice that this, instead of this being up here, instead of this part being up here, it's down below. That's because of the reflection. Okay, the reflection happened before we shifted everything up, by the way. Okay, so that's why it's not that's why it's not way down here. It comes up right to here. Okay, so this has got to be the answer. This first one. And the domain is everything except the vertical asymptote. So -infinity to -5, union -5 to infinity. And the range, you have to exclude the 1, because this can never be 1. In order for this to be 1, this would have to be 0, but never is. Now, don't get the wrong impression. You can sometimes intersect there are rational functions who intersect their horizontal asymptotes at some point. That can happen, but just not in these cases. It's not in this case. Okay, let's look at number 12. Here we're supposed to find the x and y-intercepts. Those are important. So the x-intercepts, x-intercepts are going to be the zeros of the numerator. Okay, unless it gets canceled off by something in the denominator. But anyways, let's go ahead and see if we can factor this. Let's see. Looks like 6 and 4. So x minus 6, x plus 4, and that's all over x minus 7. Okay, so nothing canceled out, so good. So that means that the x-intercepts, there's going to be 2 of them. So -4 and 6. So -4, 0, and 6, 0. Those will be your x-intercepts. And those are 0 as the numerator. Okay, Y-intercept, there's just going to be one of them. If it's a function, there's just going to be one Y-intercept. And that is going to be, you set x equal to 0. Okay, so Y-intercept is going to have this one 0. Okay, that'll be 0 for the Y-intercept. For X-intercept, the y's are 0. For the Y-intercept, x is 0. Okay, and then to find this piece, you just calculate t of 0. So in this case, I can put it into the original one rather than put it into here. (24/7), and then that just goes right there. Okay, so that's going to be, those are your X-intercepts, and those are that's your Y-intercept. Okay, number 13. From the graph, determine the X and Y-intercepts and the vertical and horizontal asymptotes. This is from the graph because there's no equation of this function, so we have to figure everything out from the graph. So X-intercepts, that's going to be where it crosses the x-axis, okay? And they crosses there and there. So these coordinates are -1, 0, and this coordinate is 1, 0. That's going to be that one. Okay, now next, the Y-intercept. That's where it crosses the y-axis. Now this is 2, which means that's 1, which means this is half, which means this is about 1/4. Okay, so 0, 1/4 right here. Okay, then vertical asymptotes. Okay, those are going to be here at 2 and then -2. Okay, so you put that in as x equals -2, comma x equals 2. Those are the equations. And then the horizontal asymptote, that will be right here. And that looks like 1. So y equals 1. Okay, number 14. Find all horizontal and vertical asymptotes of this function. Okay, so the first thing we're going to do is factor the denominator. Oops. Nothing cancels out, so that's fine. Oh, actually, I just should have done the horizontal first. Hold on. Your numerator, the highest term is 6x, and the denominator, the highest term is x². This is lower, so y equals 0 will be the horizontal asymptote. Okay, because the degree of the denominator is greater than the degree of the numerator. Okay, this is 2 and this is 1. Okay, the denominator is 2, numerator is 1. So that means as you get really large, you have like x is the largest term here. This dominates, but then x² dominates here, and x² dominates x. So it's going to be 0. Okay, now for the vertical asymptotes, they're going to be zeros of the denominator. So x equals 3 and x equals -3. Should be the ones that work. Okay, great. So now let's look at number 15. And with number 15, let's go ahead. So let's do the horizontal. They're both degree 3. The numerator is degree 3, the denominator is degree 3. So that means that you get 7, and that's a 1, right? So y equals 7 will be the horizontal asymptote. Okay, now for vertical asymptote, let's see here. Let's do this in red. So for the vertical asymptote, what you want to do is you want to factor both of these. Here you can factor an x out. And this x will cancel one of those out. But it also makes it so that, but because we have an x there, then it's undefined when x is 0. So for example, there would be for this one, there would be no y-intercept. And no x-intercept either. Okay, because even though this one has 0, 0 as a y-intercept and as an x-intercept, we're not allowed to use that because it makes the denominator here 0. Okay, so anyways, right here, this one right here, this does not factor over the reals. If you use the let's see. If you use the quadratic formula, well, this is, you can't use, if you try factoring it by hand, it just doesn't factor. If you use the quadratic formula, you get -2, so negative b plus or minus the square root of b squared, that would be 4, minus 4 times a times c. So what you're going to get is this piece right here is imaginary. So because it's taking the square root of a negative number. So 4 minus 24, that's -20, right? So this is complex, non-real. And so basically what that means is that there's nothing that makes the denominator 0 that hasn't been canceled out. So that means that you write the 3 letters D and E stands for does not exist. And that's the answer, okay? Does not exist. That means there are no vertical asymptotes for this one, for this rational function. Okay, number 16. Find the intercepts and asymptotes of this one. What is that? The numerator is 3x squared minus 24x plus 49, and the denominator is x squared minus 8x plus 16. Okay, so let's see. Let's try. What did I do for this one? Okay, so the denominator is going to be x minus 4 squared. Okay, so for the numerator, let's do this, because for the x-intercepts is going to be where the numerator is 0, right? So we can try. Okay, so for the x-intercept, we can try. So a equals 3, b equals -24, and c is 49. So let me just do it over here. X equals -b, that would be 24, plus or minus the square root of b squared, which will be 24 squared, minus 4 times 3 times 49. That's all going to be over 2a, so that's 2 times 3 in the denominator. Okay, but if you evaluate this part right here in the calculator, this gives you -12, okay? So that means it's, because of this is complex, non-real. That means that you have no X-intercepts, because this is never 0, okay? And that also means that when you put it in this factored form here, it's just like that, okay? Now, Y-intercept. Okay, for the Y-intercept, what you want to do is calculate R of 0. Okay, so 0 everything out, and you have 49 over 16. Okay, so that's going to be your Y-intercept. So your X-coordinate will be 0, your Y-coordinate, and then a comma, 49 over 16. Okay, so that goes there. Okay, vertical asymptote. Okay, vertical asymptote. Let's see, let me choose another color. Okay, so vertical asymptote, that comes from here, and that's going to be x equals 4 from the denominator. Horizontal asymptote, running out of colors. Let me try black. Okay, so horizontal asymptote, for that one, you look at the highest order terms, and that's going to be y equals 3. 3 over 1 or 3. So y equals 3 for the horizontal asymptote. Okay, so what you do, by the way, this x squared here, in the where the vertical asymptote came from, this it's squared, x minus 4 squared. That means that they're both going to go the same direction. So these graphs, as far as if you just saw only this and nothing else, then any of these could be the one. Well, no, it has to be at 4 though, right? X equals 4 has to be where it is. So that means that this one and this one, these are at -4. So neither of those can be it, based on the vertical asymptote. And then the horizontal asymptote's at 3, so that means that this one can't be it. This one can be. So it basically has to be this one here. And also it's intersected at 0, 49 over 16, so that's fine. This is slightly above the y equals 3. This is slightly more than 3, 49 over 16. Okay, and then domain and range. Okay, so the domain is going to be everything except 4. So -infinity to 4, union 4 to infinity, and then the range will be everything. Actually, it has to be above 3, it looks like. So 3 to infinity. Okay, so a lot of questions there. Let's go on to the next one. And we still have quite a ways to go. Okay, so S of x equals is this. Okay, so none of the terms are in common. Okay, great. So that means the X-intercept. Okay, so X-intercepts will be zeros of the numerator. So that's going to be -5, 0. Y-intercept. Again, for the Y-intercept, you calculate S of 0. So put zeros in here. So that's going to be 5 over 8 times -1. So that's -5/8. That means 0, -5/8. Vertical asymptotes. That one comes from zeros of the denominator. So x equals -8 and x equals 1. Horizontal asymptote. Okay, so for the horizontal asymptote, what's happening is if you were to expand this out, our leading term would be x squared. So you're looking at that. This degree is lower, this degree is higher than that. That means we have y equals 0. Yep. And then sketching the graph, you want 0 to be a, okay, so let's see, X-intercept -5, 0. So that looks, let's see, X-intercept. So that looks good. That one doesn't look good. That looks good. That one doesn't look good. Okay, now the Y-intercept 0, -3/8, 0 should be down here. So that looks good right there. And that one doesn't look good. It should be down here. So based on that, based on those two criteria, we've eliminated those three graphs. But let's check the other stuff out. Vertical asymptote, x equals -8. There's -8 right here. Here's 1. So those are good. You got vertical asymptotes there and there. Horizontal asymptote, y equals 0. That's good too. Okay, so this is the only one that could be. Okay, then for the domain and range, we have two vertical asymptotes. We have two values that we need to avoid, -8 and 1. So -infinity to -8, union -8 to 1, and then from 1 to infinity. So we have to eliminate, we have to remove -8 and 1 from the domain. Now here is a case where y equals 0 is the horizontal asymptote. It intersects 0 right there. So this is just, so we don't have to eliminate anything. So it's -infinity to infinity is going to be the range. Okay, number 17. Okay, so let's go ahead and find the X-intercept. So let's try to, I think we can factor this. Factor the numerator, it factors into +9 and -1, and then denominator factors into +4 -1. Okay, so that means that because there's x minus 1s here and here, that those are going to reduce, but it's going to leave a hole in the graph. So let's just remember that. So our X-intercept is going to be -9. Okay, so -9, 0. That's going to be our only X-intercept. 1 was looking promising until we had an x minus 1 here too, and we had to cancel it out. Okay, Y-intercept, again, that's going to come from calculating R of 0. It's easiest to do it from this one. I guess this one would be okay too. It doesn't matter. Okay, so -9 over -4. So that's going to be 9 over 4 is going to be our Y-intercept. So 0, -9 over 4. Vertical asymptotes. That's going to be -4. X equals -4. Okay, horizontal asymptote. That is, you look at that right there, and it's y equals 1, because that's 1 and 1. Because these are the highest terms. So y equals 1. They have all those things there. Okay, so X-intercept -9, 0. Huh, that doesn't intersect there, so that's off. That looks good right there. That also looks okay. That one's off. So that means that both of those are eliminated. Okay, now the Y-intercept is 0, -9 over 4. So that's off. It should be down here, at -9 over 4, or like like that one. That one's good. So this is going to be the graph. You got a vertical asymptote at -4. That's good. And horizontal asymptote at 1. Wait a minute. Wait a second. Oh, I don't know. Okay, so I made a mistake here. So this is really bad. This is 9/4, not -9/4. So that means that this one was fine. That means that was fine, which means that this was not fine. Okay, so that means that one's out. All those are out. This is going to be the correct graph right here now. Okay, -4 is the vertical asymptote. That's fine. Y = 1 is horizontal asymptote. That's fine. Also, let me point this out. This part right here, you know how we had this -1 in the denominator? That leads to this little open circle right there. That means that the function is not defined at that point. It's not defined at that point. If you take this piece, set x = 1, you have 1 + 9 / 1 + 4, which is 10 / 5 or 2. This is going to be not in the range because that's open circle right there. And there's no other the graph. There's no other place where that intersects there. Okay, so when we go to write down the domain, we know to exclude 1 and -4. We have to exclude 1. We have to exclude 1. And then 1 to infinity. So we got to do that one. But we also have to exclude 2 from the range. Okay, so for 1 is being excluded also because that's our horizontal asymptote, and it doesn't look like it intersects the horizontal asymptote. So -infinity to 1, and then from 1 to 2, we have to exclude 2 also. Like that. Okay, so that's why that came in there. We're taking 2 out of the range. Okay, one more problem. Almost there. Okay, one more problem. Find the intercepts and asymptotes. Okay, so this is a problem with the slant asymptote. Okay, so we really need to do this one. So let me show you how to find the slant asymptote. So to find us, that's where the degree of the numerator is greater than the degree of the denominator. Okay, so if they're equal, then it's not going to have a slant asymptote. It will have a horizontal asymptote. Okay, so the degree of the numerator is greater than the degree of the denominator. Okay, that means it doesn't have a horizontal asymptote. And what you need to do is use long division, or just use division. We can use synthetic division also in this case. I guess that would be okay. But let's just use the regular division because, you know, it comes down to that more often than not. Okay. So it's x times x is x squared. X times -4 is -4x. Then you need to remember to subtract here. So that's 0. This one is actually 6x plus 4x. That's 10x. And then you have a plus 10, because 10 times x is 10x. 10 times, excuse me, -4 is -40. Excuse me. Okay, subtract, that goes away. This is 45. Okay, so it's important to write down what this is. So this long division is telling you that this right here, this rational function is equal to this numerator. I mean, not numerator, this piece right here, x plus 10, plus the remainder divided by the quotient. Okay, now, let me point something out. As x gets larger and larger, this piece goes to 0 because this is getting larger. Also, or as x goes to negative infinity, this goes away. Of course, this goes to infinity, or this goes to negative infinity, the whole thing. But I'm just letting you know, this piece, as x gets really large, this piece is insignificant. That means that our slant asymptote is going to be this piece, y equals x plus 10. Okay, so that piece, that's where you get the slant asymptote from. Okay, now, vertical asymptote. I guess, okay, so for a vertical asymptote, what I should have done, I guess, is factored the numerator, because it could, I guess, well, that's not going to, now we know that that's not going to, that nothing's going to cancel out, because if it did, then we would just get some number here. So this is x plus 5 and x plus 1. So that means that this denominator gives us our vertical asymptote. Okay, so vertical asymptote is x equals 4. Okay, so that one is out because that's negative 4. It should be over here. That one looks okay. It looks like it goes to 4. This one looks like it's out because it should be over here. And that one looks okay. And then for the slant asymptote, y equals x plus 10. That is, the y-intercept is 10, and the slope is 1. So that looks good. Here, no, it should be over here. So this is off. And the slope should be 1, not negative 1. Okay, so that means that this is the only answer that it could be.